My name is Sean Falconer, and I lead developer relations and product marketing at a company called Skyflow. Before Skyflow, I led and built and ran developer relations teams at Google for a number of different products there. Before Google, I was a tech founder, so I was a technical co-founder of a company that I ran for 7 years and eventually sold that business. It was in the HR space, and before that, I worked in bioinformatics. So I have a long history of doing engineering and product with a lot of really sensitive types of information, everything from clinical trials data to essentially employee record data. And that kind of brings us to the topic of conversation today, which is stop contaminating your database with PII. And yes, thank you. If you're unfamiliar with what PII is, that stands for personally identifiable information. You can think of that essentially your customer data or your user data, things that can be used to essentially identify an individual. And for you to kind of, I think, understand my perspective on this and the types of things we're going to be talking about today and why you shouldn't be polluting your database essentially with your user information, we kind of have to zoom out a little bit and look at the macro level of why is privacy hard? So why is data privacy, data security, compliance, these types of things so difficult for various businesses? And there's, of course, multiple reasons, but I think a big part of it has to do with essentially the history with which we've actually built systems and the way we've thought about customer data. So if you go back to essentially the 1980s, the first sort of PCs finding their way into people's homes or into businesses, we were building systems essentially in an on-prem world with disconnected computers, and it didn't really matter if we treated all our customer data essentially the same way as any other application data, because the worst that could happen is someone would have to physically get access to the machine, and then they might get access to a little bit of information, but it's not that big a deal in comparison to the world that we live in today. But we've taken essentially that design philosophy and the way that we built systems in the 1980s, and we're still doing that today, essentially at the scale of the cloud with global businesses serving millions or even billions of users. And on top of that, essentially, we've adopted this philosophy of move fast and break things that was popularized at Facebook. And the idea of essentially protecting customer data or thinking about it in any other way than just regular application data has been lost on us, and we continue to essentially just build out systems, release them in the wild, and then the idea of essentially protecting customer data is an afterthought at best. And that has led to essentially the world that we live in today, where on a weekly basis, there's essentially a major data breach at a major company. In the last year, Okta, Uber, Robinhood, and many others have all had data breaches. Even in the last week, a company called Chegg, anybody heard of Chegg? They've had their, I think, 4th data breach in the last 3 years. They're now under investigation by the FTC. But what Chegg does is they actually are an application for helping children with their homework. So they had a data breach of 30 million records of children's information this past week, which is pretty terrifying and pretty awful. But this kind of thing happens all the time. The IRS in the United States had a data breach this year. The San Francisco 49ers in the city that I live in had a data breach of 21,000 social security numbers. So this thing is happening all the time. So why is it that these super well-resourced companies with tons and tons of tech talent that can buy any tool that they want or build anything they want are still struggling with this problem? And of course, a lot of it has to do with the history of our thought process about data, but it also, if you think about these companies, even though we blindly trust them with our data, their job, their sort of primary objective is not to protect it. If you work for Uber, your primary objective is to deliver a driver to you as efficiently as possible. If you work for Instacart, your job is essentially to deliver groceries to someone as quickly as possible, and that's what you're hiring for, that's what you're optimizing for, and basically everyone in your company is consumed with this problem 24/7 of thinking, how do I optimize that flow? So the idea of essentially protecting data is an afterthought at best, and we end up in a situation where we've already architected these systems, and then we retroactively and reactively apply duct tape and chicken wire to essentially try to protect this. We're like, okay, well, we have a problem, we'll sprinkle some encryption over here, we'll add some tokenization. Oh shit, everybody in our company has access to the production database of our users. We should probably shut that down, so they add data governance in, and then they have to buy some tool to essentially create synthetic data so that it looks like production data, so that engineers can still test against things that look like production data. And essentially, they just band-aid these different solutions together, and that's why essentially none of these companies essentially have a handle on this problem. And there's this fundamental challenge that goes back to that 1980s thinking where most people don't realize that, oh, well, actually, it's all fucked up. That's the world we live in, unfortunately, at this point. And most companies, because they've architected the systems in a certain way, and now they've tried to stitch these different systems together to protect it, they are in a situation that's essentially an unwinnable situation, which is why we keep having these data breaches, despite all the resources available to these different companies. And no one's really taken a first principles approach to how do you solve this problem. And I think the big fundamental issue is that we need to understand that essentially not all data is created equal. Some data, and we're talking, of course, about sensitive customer data, things like people's names, date of birth, home address, healthcare information, financial information, simply requires better protection than other forms of data. How many people here put their passport or maybe their wallet or some other type of, something personal in the safe in their hotel room? A few people, I did. Yes, so why did you do that, but you didn't do it with your socks and your underwear? Because, well, I can't speak for you, but I did not do it with my socks and underwear anyway. But they're fundamentally different objects. The level of sensitivity of my passport is much different than the level of sensitivity of my socks and my underwear. And the other thing about essentially PII is most of this stuff, like a date of birth, it's not simply just a string, even though we treat it like that at a database level. It's actually a data structure where each of the components, the year, the month, the day, has specific meaning and determine specific uses of that information. We call things like a phone number, a social security number, a passport number, a credit card number numbers, but they're really numbers. You don't multiply a phone number by your credit card number and divide it by your passport number. Each of these things have semantic meaning when it comes to PII, and essentially we need to develop technology that understands the underlying meaning that these things are data structures and the usages of them. But instead we end up putting them in their database where they're treated essentially the same as a click on a web page. And the big issue here is that all of this data is really special, and as such we need to treat it as something special, just like those special physical documents like your passport, or for me, in my home, essentially my marriage license, my green card, my children's birth certificates. I don't have those in the junk drawer in my kitchen with my batteries and my flashlights, because those are fundamentally different things. And if someone breaks into my home and steals my batteries, it's mildly annoying, but I can replace them. It's not that big a deal. But if someone steals my daughter's birth certificate, besides having to explain to this cute little girl that I've lost her birth certificate, essentially I feel like I've failed as a parent. Because one, it's very sensitive, and the other thing is you can't really replace PII. Like the date of birth of my daughter, her name, all those things are fixed for her life. So if that information gets out, it's out forever. It's not even like a credit card that you can cancel and essentially replace that number. So it's very, very sensitive. And the same care that essentially we apply to our personal data, or personal artifacts in our real life, we need to apply the same care to customer data. But what ends up happening essentially is we collect the data and we stuff it in a database along with all that click data and everything else. And then that ends up being replicated and shared in our downstream systems, in our log files, and so on. So if we look at sort of a simple example here, it's a little faded out, but any modern system, they need a lot of stuff to just operate. Like you have an HR application for your existing employees, you have an applicant tracking system for hiring pipeline, you have a CRM for customers. Each of these have databases, their own representation of users essentially. Maybe they feed down into a data lake or down into a data warehouse. And over time, you add more and more applications. And essentially, this spider web of dependencies grows more and more over time. And what you end up with, essentially, is customer data being copied, replicated, and fragmented throughout this entire system. So you end up with sensitive data all over the place with many, many copies. So imagine instead of having your passport in the safe in your room, making 1,000 copies of it and distributing it all over this resort and then trying to protect all those thousands of locations. That's a much harder problem to solve than having that one copy that's in the safe in your room. Yet that's what we do with data all the time. So then we end up applying essentially that check-in wire and duct tape solution to all the nodes and the edges of this graph. But this is a fairly simple system. 20% of enterprise companies are collecting data from over 1,000 different sources. So these graphs get much more complicated much faster. And it's essentially just an intractable problem. Now, that being said, data privacy and security, of course, is a complicated space. There's lots of tools and technologies that you can use. There's a whole spectrum of things that you can do. And what we end up seeing is that because something like privacy is sort of holistic to an entire company, but companies aren't really set up from an engineering perspective that way. They essentially have squads that work on specific features or certain product lines. So even if a part of your business solves this problem or is focused on this problem, they might do it in a different way than some other part of your business. So you end up with teams applying different sort of approaches to the same sort of problems, and that leads to even more organizational complexity. There's also this trade-off a lot of times when we talk about privacy and security between the utilization of that information. We collect it so we can use it, but as we add additional layers of privacy and security, it might make it harder to use. So we need essentially technology that understands the underlying data types. So PII understands that a date of birth is a date of birth, or that passport number is a passport number, but also is able to balance essentially this push and pull between privacy, security, and the utilization of that information. So how do we solve these problems? Of course, and that's the big question that all these companies are wrestling with. Now, if we look at some of the leading technology companies in the world, companies like Apple, Google, Netflix, all of these companies, as well as a handful of others, have pioneered a technology known as the Zero Trust PII data privacy vault. And essentially their key insight, which goes back to what I was talking about earlier, was they recognized that their customer data, which is core to their business, is something special. So they decided to treat it that way, and they built these PII data privacy vaults, and they moved their customer data essentially out of their existing infrastructure, wherever they were storing it, and into the vault. And what that does is it creates an isolated single source of truth of the PII, similar to having that one copy of your passport, and it effectively de-scopes their existing systems from the responsibilities of data privacy, security, compliance, and so on. Sounds amazing, right? So what exactly is a data privacy vault? Well, a data privacy vault is a type of technology that isolates, secures, stores, and tightly controls access to manage and use sensitive data. So a big part of this is based around this principle of isolation, which isn't like a new concept. So if you walked into an office building from even 50 years ago, the employee records, the customer records, the financials of the business are probably not just out in the open with all the lunch orders of the day. They're most likely under lock and key in a file cabinet, or maybe even better, within some sort of vault within the business, with very few people having access. And that essentially is the non-digital version of isolation and protection of data and data governance. And of course, we can do much better with modern technology, but the first part of essentially a well-designed data privacy vault is isolation. So it needs to live on a segregated network, have privileged access. All the access essentially needs to be logged for auditing purposes, which is also required for certain compliance regulations as well as security regulations like SOC 2. And we can use things like machine learning on the audit logs to actually detect abnormal patterns so we can proactively detect a data breach. A lot of times, a company has a data breach and they don't actually find out for 6 or 9 months after it's happened. So imagine having to write an email to your 10 million customers and tell them, we're sorry, customer, your information's out there on the web now, we had a data breach, and by the way, it happened 9 months ago. That's a pretty embarrassing email to send. It happens all the time, so we can be proactive, essentially. This is, of course, secure storage, so we need built-in privacy-preserving technologies, things like encryption, tokenization, data masking, other ways of essentially utilizing this data without sort of exposing our systems to it. It's core infrastructure, so we need enterprise-grade performance. It's your customer data, so you need high availability, throughput, support for structured and unstructured data. We need to basically manage or govern access to the data based around the principles of zero trust. So zero trust means that no one or no thing has access until you explicitly give it access. And you should be able to control access based around the business requirements of the service that's accessing that information. So most services or most parts of our application, they don't need access to customer data, or they need very limited access. So you should be able to control essentially what columns of data, what rows of data, and essentially how they actually see that information, whether it's partially redacted or fully redacted or in clear text, depending on what it is that you need to do with that data for that service. And finally, we need to use this data. We collect it so that we can actually utilize it. Like we can mock it up, throw away the key, but it's not super useful. So we need things like privacy-preserving analytics, database-like access so that we can essentially incorporate it into our existing stack using familiar technologies. We need to be able to run assertions against the vault in order to get results, but without actually seeing the underlying data, perform cloud functions on the sensitive data, and even securely share it with third parties. So if we look at sort of an example, sorry, my lines are disappearing from the brightness, but there's lines from the app down here, over there. But essentially, simple application. We have our application up here. They're going to have some data storage and processing, cloud, services on top of it. And when you use essentially the vault architectural pattern, you're making the choice of essentially moving your sensitive customer data over into the data privacy vault, and not in essentially your existing sort of services and stack and infrastructure. So now, in this case, whenever we need to actually use any of the data, we're going to go to the vault to do that. So that's to run assertions or share the data or perform some sort of processing or analytics, including talking to third parties. So let's say you want to programmatically send a text message to somebody using Twilio's APIs. Well, in a non-vault world, you would probably have a customer record in a database with a phone number, and you would query that record in your backend, pull it, make an API call with the phone number. And the problem there, of course, goes back to what we've been talking about, is the phone number, you're now responsible for protecting it. So you've got to protect all the places in your infrastructure where that phone number is going to touch, including log files, observability tools, downstream services, and all these different places. In the vault world, what we're doing is we're storing the phone number over in the data privacy vault, and we're going to store essentially a pointer or a token that's non-sensitive representation of the original data in our application database. So we can use that essentially as a pointer to the original value, but it has no mathematical connection to the original value. And to call something like Twilio, we're going to still query our database, pull the record, but instead of the phone number being there, we'll have essentially this random string that's a token. And then we can call the data privacy vault with that random string. The vault knows how to return it to its original value, and then it can call Twilio on your behalf and then proxy the response back. So it's essentially you're insulating your system from seeing that phone number, but still being able to utilize it the way that you want. It's the same thing when you call your Uber driver. You don't see the Uber driver's phone number. You see essentially a proxy to their phone number, except back in the early days at Uber, you used to actually see the phone number, and that led to a lot of privacy problems, but that's a different story. All right, so another example here, if we have essentially a linear stack here, in a very simple security model, you have build some sort of fencing essentially around your backend. And then everything that's in the fence or within the perimeter in the app backend and beyond, you trust that they have that they're allowed to be there. So everybody, once you're in the app backend, can essentially read alice@email.com and their credit score. In the vault world, what we're doing is we're moving alice@email.com over to the vault, and then in the application database, we're storing a pointer essentially in the form of a token. So this is essentially, you can think of it like a random string. And there's different ways of generating all kinds of different types of tokens that we'll look at, but essentially it's a random string. That way, even if someone stole the database, it's meaningless unless they have a way to essentially return it back to the original value, because you can't even reverse engineer it. It's not like encryption. It's essentially, there's no mathematical formula for generating that token. So, of course, there's going to be parts of our application that need to be able to read PII. And we want to be able to govern access to allow those parts of the service to see something like alice@email.com. Other parts are going to need partial PII, and then probably most of our application doesn't need PII at all. So if you've ever worked on a large-scale system with thousands or maybe millions of lines of code, and you think back, how many lines of code actually needed to see someone's email address? It's not very much. Yet we typically architect things or build things in a way where essentially everything can essentially access the email, and all it does is increase our compliance burden as well as the potential attack surface that we have. So we just shut that down essentially. So the readers that need to see PII, well, they can read alice@email.com. Maybe this is like Alice logs into her account, she goes to the account page, and she wants to be able to see her email. Well, we can essentially bring that, render it, and re-identify it on the front-end system. Some parts will need partial PII, so they can see essentially a mass value in this case. This could be maybe a customer service portal that needs to see some version of the email, but not the full email. And then, of course, most of the systems don't need PII at all, so it's essentially redacted. So if we go back to this example that we talked about earlier, where we have essentially the spider web of dependencies and essentially customer data ends up all over the place, making it really hard for businesses to essentially answer basic questions like what data are we storing and where is it stored. Recently, Facebook actually had to share where their customer data is, and they shared a list of 56 databases where they think their user data is, because they don't know. And the former head of security at Twitter also announced recently in the last few months that Twitter has no idea where your user data is. And it's funny as an outsider, but this is a very common problem across many, many, many companies. And that makes compliance hard and also makes essentially whether you know things are locked down. So if we change this essentially to the vault architecture, things get a lot simpler. So now we essentially have a single source of truth, that single copy of your passport, that's isolated and protected outside of your existing infrastructure. And when it comes to answering questions like what data are we storing and where is it stored, well, it's stored in the data privacy vault. We can look at the schema of the vault to know what we're storing there. Are we sure that things are compliant? Well, now the regulated data essentially lives within the vault, as long as the vault is compliant, then it doesn't really matter what's going on in the rest of our system because we don't have essentially sensitive data there. And then, are we sure that our data is locked down and that we're keeping it safe? We have a single point of entry based on a zero trust model through an API. So now we can essentially govern access where the billing application is probably going to need a different level of access than something like Talent App or machine learning because the billing application actually needs the issue transaction. So we can essentially reduce the scope with which we're utilizing that sensitive data and to essentially the services that actually need it. These different companies, Apple, Google, Netflix, there's other ones as well, Goldman Sachs, all pioneered this concept of the zero trust PII data privacy vault, but they built it in-house. It takes a lot of resources to build. As an example, Shopify built something similar. It took them 100 engineers in nearly 3 years. So most companies don't have 100 engineers to work on something that's not like essentially their core product. It just doesn't make sense. It's just like you don't go and build a SIP server and connect it to a carrier and then put a REST API in front of it. You go and you use the Twilio API to send a text message. And you don't, go and link into banks and credit card networks usually. You use something like Stripe to do payments. So it doesn't make sense to essentially build this for most companies. But that was the inspiration for the company I work with, Skyflow. Essentially, we took inspiration from these companies and built the data privacy vault for everyone else and made it available as a simple API. So as we start to transition into looking at a demo of this stuff, essentially we're going to be using Skyflow to serve the need of the data privacy vault. So I think the easiest way to so we talked about essentially the problems in the data privacy space, why companies are failing to address this issue, and then essentially this architectural pattern of the data privacy vault and how it fixes a lot of these problems. Now we're going to actually transition to how can we build a modern application using sort of the modern tools that we're all familiar with, leveraging the data privacy vault. So the application we're going to be talking about is a fake company that I made up called Instabread. It's like Instacart, but only delivers bread. It's part of the gig economy. So essentially it's a two-sided marketplace. You have your bread enthusiasts that are the clients, and they want to be able to order bread on demand, and then you have your Instabread gig workers or shoppers that go out, get the bread, and deliver it to the clients. And the application we're going to be looking at is the Instabread shopper sign-up experience. So if you were building this product, there's certain requirements that you need to adhere to. So it should be mobile first because gig workers are on the go, they're on their phone, so they need to sign up on their phone. They need to be able to supply their account information, so essentially there's PII collection so that we can share that information with Instabread and they know who they are. They need to be able to select bakeries or grocery stores they're willing to travel to. They need to be able to supply their banking information so that they can get paid. And then because this is a modern application and we want to leverage the wonderful tools available in the modern data stack, we want to be able to have some sort of analytics engine where we can analyze what's going on in the business, deliver better products and better features for our customers. So what I use to build this is the front end is React, and then the back end is Node.js. The application storage is AWS DynamoDB, and then as I mentioned, the data privacy vault is supplied by Skyflow. And then the data cloud, I'm using Snowflake. So essentially that's going to be your analytics store and where we run our sort of analytics and reporting. And then for performing bank money movement to pay our gig workers, I'm using Move.io, which is a developer platform for essentially managing banking information as well as doing money transfers. Okay. Now, the first part of this, we're going to talk about data collection and ingestion. So I'm going to do this live, which always goes right. So this is the Instabread shopper experience. So I'm going to go ahead and sign up, get paid to shop, and deliver bread. So the first thing is account sign up. So I'm going to put in my information here. We'll put in my zip code, my phone number, and create an account. Now, in any sort of security, privacy conscious application where we're using the data privacy vault pattern, we want to basically send this data directly to the vault and not have it touch any of our infrastructure, just like when you collect payments using something like Stripe. So that data went directly, logged out, from the front-end application and into Skyflow once this loads. Right. So this is the Instabread vault here. And once that loads, we'll see essentially in the shoppers table, there's one record here, which is for buying. And we see this information essentially partially redacted, so it's masked, as well as redacted. And that's based on essentially the role and the policy that's assigned to my user. So I'm allowed to see essentially this record in this format because I've explicitly given myself permission to do that as the owner of the vault. But the other thing about the vault is it actually understands that email or phone number, these elements of PII, it actually understands those as data structures and understands the semantic meaning of it, which means that through a technology which we developed in Skyflow called polymorphic encryption, you can actually run fully encrypted queries against the encrypted database without actually decrypting any of the information. So I can do something like look up someone's phone number by the country code or the area code without actually decrypting any of that information, or performing something like dynamically masking it where I need to pull it back unencrypted and then mask it in real time where it ends up essentially in a log file somewhere. And we can essentially tokenize this information in a variety of different formats. Now, at the same time, since we're using DynamoDB as our application storage, the data also gets pushed down into DynamoDB, but instead of the plain text values, we're getting tokens. So the first name in this case is the UUID, but the email is what's known, if you can see it, is essentially a format preserving deterministic token. So it still looks like an email, and this is controlled by regex, so you can make it look like a gmail.com email if you want, but essentially it's a random string. But it still looks like an email that way. If my database or any downstream services expects it to still look like an email, I don't break those things. And then if we go over to Snowflake here and execute this query, then we also see the data in Snowflake here in a JSON blob, but is also tokenized. So none of the essentially sensitive data is making it down into the database or the data warehouse, and I can still run analytics on this data. Like, it doesn't really matter that Sean Falconer at skyflow.com is stored in the data warehouse versus some random string, as long as that random string is consistently generated every time we tokenize my email. So I can still run counts and joins and group bys and all the types of analytical operations I want to against that string, but against essentially non-sensitive data. All right, so we're going to continue here. So how Instabread works, get paid to shop, check out, then head out. All right, so the requirements are you have to be over 18, able to lift 40 pounds, eligible to work in the United States, and love bread. Doesn't love bread. I meet the requirements that I can choose where I'm willing to shop, so it's a Safeway and Lucky's. And again, this data, even though this data is probably not technically regulated, I'm storing it in the vault because if I'm willing to travel to those locations as a shopper, it probably says something about where I live in San Francisco. And as a business, I wouldn't want that showing up on the front page of the New York Times. So store it in the vault, protect it, essentially. And here you again see the data is essentially a form of redacted and partially redacted as well. I'm going to grab the Chase routing number for California because I forgot to do that. And now I'm going to put in my direct deposit information and create my banking information. So again, this data is going to go to the vault, and then we're going to essentially create the account and move. And we can go take a look at the move dashboard here, actually. Oh, lovely. Give me 1 second. I do like the fact that they're using two-factor every time. Well, we'll come back to this once the email shows up. But essentially, congratulations. We're ready to shop. So through essentially the magic of the demo experience here, I've already earned $64 in delivering bread, thank you. So I can cash that out, and I'm going to hit the cash out button here. And essentially, now Instabread is going to send me that money. And if we can get back into Move, we can show you what that looks like. Oops, 4, 6, 7. All right, so this is the Move admin dashboard. We can see my account was here. There's that bank account I added. And if I go to transfers, indeed, I have $64 pending from Instabread to the account that I just created. So all that's happening. We're still utilizing all that data that we want to collect and need to use essentially to build something like Instabread or any type of modern application, but we're insulating our systems essentially from seeing it. So if we go back here, we can take a look at the breakdown of how this is working from an architectural perspective once this page loads. So as I mentioned, whenever we're building something where we have privacy and security in mind and we're using the data privacy vault pattern, we want to de-identify the sensitive data as early in the life cycle of the data as possible. So in the Instabread example, that's essentially a collection in those forms. So we're going to send that data directly to Skyflow. We can do that through front-end SDKs, or even better, you can use something called Skyflow Elements, which is similar to like if you've ever used an integrated payment processor like Stripe. Those form elements from Stripe are actually running on Stripe's infrastructure through iframes. You can do the same thing essentially with Skyflow, but for any PII element. So that way, even from your front-end application, you're insulating it from seeing any of that data. It goes directly to Skyflow. Skyflow is going to send tokenized forms of data back, just like we saw in the demo. And then we can call the Move APIs with the tokens via Skyflow. So essentially we're proxying the call to move by using the data privacy vault, and then the vault knows how to return those values to the original values and send them to move. Then we're going to send all that data downstream to DynamoDB, and then I have a Lambda function. This is essentially the start of the ETL pipeline. The Lambda function gets triggered whenever new data gets written into DynamoDB, and then takes that data, writes it to a Kafka broker, and then through the Kafka connector for Snowflake, writes it down into Snowflake. So effectively what we've done is we've de-risked and taken out of scope from a compliance perspective this entire surface area. And it's limited essentially to the data privacy vault. All right, so we talked a little bit about running analytics from the data warehouse. So we can do a lot of the types of analytic operations we want against tokens, which is great. But sometimes we might need to return some value to the original value in order to run a report. For example, if we wanted to do something like compute the shopper density by zip code, then we could run a query like select count from the shopper's records, group by the zip code, and we can do that against tokenized data as long as the zip code is consistently generated. But in the report, we don't want to see a bunch of random strings that represent the zip codes. We want to return it to the zip codes. So how can we do that? Essentially, we can do that through an integration that we created between Skyflow and Snowflake in this case, where we can essentially give Snowflake the power to detokenize those values based on the user profile or the data analyst that's running the query. So we're going to look at the architecture of this first, and then we'll jump into essentially the live demo in Snowflake to show how this works. So here we have some sort of data application that like a data analyst is running. So they want to run some sort of query against their data warehouse, and it's going to look like select ID, detokenize this token as name, detokenize this other token as email, and we want to be able to get the original values, assuming the data analyst actually has the permissions to do that. So obviously Snowflake doesn't know what detokenize means, but we can create an external function in Snowflake called detokenize, which essentially makes a REST API call into an AWS API gateway, which then calls a Lambda function. The Lambda function uses the secrets manager to essentially pull the credentials for that user or the vault, and then it can securely call the Skyflow data privacy vault with the tokenized data. The detokenized data is going to then come back out and be rendered essentially to the end user. And the key here, besides essentially the integration from an external function standpoint, is that the user in Snowflake needs to be connected essentially to the policies and the roles set up in the Skyflow vault that give essentially this explicit access for that user. So only this user can essentially make that call and get back this data. So we'll take a look at how that looks in Snowflake. So in Snowflake, we can generate, let me scroll down, a function like this. You can see it, where we have detokenize, and we're passing in a string, which is the token. And then this is just going to call essentially this API endpoint, which is an API gateway set up in AWS. So I've already done that. So now I can run a query like this, where we're going to pass in the email, the first name, and the last name, which are the tokens inside Snowflake, and it's going to return, if I pull this up so you guys can see, essentially it's returning my information, in this case, in plain text, because essentially it's going through that process of calling Skyflow securely based on the rules and the policies that are set up. Now, if we run another one here, let me scroll down, run this query. So in this case, once this executes, we're going to get back some plain text values for the first name, last name, and email, just like we saw before, but in this case, the phone number is masked, because essentially in Skyflow, for this particular user, if I go over to the role and look at the policy is set up where they have plain text read access to name, email, and last name, but the phone number is masked. And now, if suddenly my business requirements change and we say, oh, well, the analyst doesn't need email, they only need a masked version email, all I have to do is update the policy, and when I come back and re-execute the query, I don't need to deploy any new code or deploy a new service account or anything like that. Essentially, now I'm getting a masked version of the email as well as the masked version of the phone number. So I can essentially update in real time based on what my business requirements are around how users or different services need to be able to see this information. All right, so that's a little bit about querying. And the last thing we're going to talk about in terms of Instabread, or even the larger issue, is solving for data residency. So data residency is one of the biggest privacy challenges, compliance challenges that's facing companies today. So if you're unfamiliar with this concept, It's a little bit nuanced. It can change, a little bit from country to country, but the sort of gist of it is, if you're doing business, essentially, with citizens of certain countries like Germany, Singapore, Canada, Brazil, there's a bunch of them, then the citizens' data that you're collecting has to live in a data center deployed within that country, essentially, is the gist of it. So going back to what we talked about earlier, if you already built these systems that essentially have a plethora of data that's all over the place, you're running these global data centers, really, really hard to deal with this problem, because now, how do you disentangle that data, shard your customers into these different regions? And it's actually blocking certain companies, from the United States doing more work, or more, going internationally, especially in Europe, or some European companies from essentially going to other parts of the world. So how do you solve this problem? Well, as a first cut approach, you could essentially just make the choice that we're going to take our US customers, and they're going to communicate essentially with a data center or a cloud infrastructure that's deployed only to US regions. So using essentially the same Instabread backend that we talked about before. And then for our EU users, we essentially just copy this entire infrastructure and deploy it only to Europe and put our European users there. Now, there's some fundamental problems with this approach. One is, well, I'm sure you can comment, Steve, AWS and Snowflake would like you a lot because you're going to get a very big bill at the end of the day to do this. And then the other thing is, it's hard enough to run one global centralized infrastructure, let alone like 10 because you're operating in 10 different countries with data residency. Like, it's just like, it's not even feasible. It would just completely destroy your company. So it's not a reasonable thing to do. So how do you solve this problem? Well, you can use, again, the data privacy vault pattern where we take our US users and essentially we send their sensitive data or their regulated data to a US deployed data privacy vault. And then we take our EU citizen data and we send that to a data privacy vault deployed to Europe. And then everything else stays the same. We're just sending non-sensitive tokens downstream. So our sort of central data center can stay as is. And now we can actually run global analytics, because in essentially the other view, you couldn't even run global analytics because everything's essentially siloed in these different regions. So it makes even data residency much, much simpler. And really, the big thing here is that with the data privacy vault, you're making data privacy an architectural decision, and rather than something that's kind of a band-aid solution afterwards. And there's something called privacy by design, which is a framework for thinking about privacy, and it has certain rules or suggestions like proactive versus reactive. But essentially, the data privacy vault is the engineering or architectural solution to the framework of privacy by design. It makes it actionable, essentially. And as long as you're making this sort of architectural decision to say, my customer data is special, I'm going to put it in a special spot, then it makes a lot of the challenges around data privacy, data security, compliance, and even data residency as simple as a handful of API calls like we've seen throughout the demo. And the last thing I'm going to say is that privacy is a fundamental human right, and I think it's the responsibility of everybody working in the technology industry, as an engineer, as an architect, as founders of companies, to keep that in mind and essentially be responsible, good parents, essentially, of our customer data and not treat it essentially like batteries and flashlights. So I want to thank you all. Thank you all for listening and turning up on the last afternoon here. And of course, happy to take questions and talk throughout the conference, but if you ever want to contact me, you can find me, Falconer at skyflow.com, or on Twitter under the same name. And if you like talking about privacy and security, I host a podcast called Partially Redacted, which you can find at skyflow.com/podcast, as well as you can join or check out the community at skyflow.com/community. So thank you. Anyone have questions? If not, I'll ask myself questions. What's that?
Oh. Sure, you showed the example of where you have a plugin that's available for Snowflake. But when you start to expand on other things that are specialized, like full text search engines, right? Like if you're using something like Elasticsearch, and you're trying to, is the intent here to say like data privacy vaults will have extensions for other databases like that?
Yeah,
and other technologies?
So the Snowflake one was just an example. You could do this with Redshift or any data warehouse, and actually we have, I can't go into all the details, but we have someone we're working with that has an Elasticsearch use case as well right now. So essentially, in the case of Elasticsearch or any of these places where you essentially want PII to exist but be searchable, most of the time you can solve that by essentially pushing tokens into those places. Now, Elasticsearch supports a lot of powerful search features that don't work for all forms of tokenization, so that's something that you have to kind of think through. So it depends on sort of the use cases that you're looking for. So if you're doing something like exact matches or group bys, counts and things like that, that's fairly simple to do with tokenization. If you need to be able to do something where you're doing a partial like substring match, it's not going to work from a tokenized format. There, essentially, you would need to do that kind of specialized analytical operation, most likely directly against the vault. So that's one of the reasons we developed polymorphic encryption, so that you can perform analytical operations against the vault without essentially revealing all the underlying data, because you've been doing it fully encrypted. So there's kind of like use case by use case, but a lot of them can be solved with tokens, but there are, of course, more advanced analytical operations where you might need to go back to the vault to do those kinds of operations. I think I saw someone else with the hand up. So if you're comparing to not doing anything versus doing something, of course there's going to be latency issues, because as soon as you do something, there's like going to be additional cost for it. But I think the question is like, if you have to do something because you don't want a data breach or you need to be compliant, then I think it's going to be harder to find a better solution to this. And we work with a large range of different businesses. Our largest customer is IBM, which has a massive amount of data that they're running through us, and they're able to do it essentially at an enterprise grade performance. And if you look at a company like IBM, IBM is, if anybody's heard of fully homomorphic encryption, they are one of the leaders in essentially the research around that technology, and they're the first company to ever build a fully homomorphic encrypted database about 5 or 6 years ago. And essentially homomorphic encryption is like the holy grail of encryption, where you can perform any operations over encrypted data. The problem with this is like it's incredibly slow. Like the database that IBM created took like 3 minutes to query 50 records, so it's not ready for prime time. But they are essentially the leaders in that space, and they've chosen to not leverage their own technology, but actually work with us to solve their problems. So I think from a performance standpoint, is there going to be more lag at the kind of minutia level versus not doing anything? Yes, because whenever you add something, it's going to add a little bit of latency, but it's going to be very performant for you as well. Yeah. Any other questions? So I'll ask myself one question, what people think, because I answer questions all the time. One of the big questions, of course, that people ask is, if I've already built a system, how do I switch essentially to this part? How do I disentangle my infrastructure? So for the most part, well, I would say one thing is, you have that same challenge if you're moving from on-prem to cloud, but I would say that problem is even worse, but people still do it because it's worth it for, whatever reason, the scale of cloud and all the services there. So it might be worth it to do that over time anyway, but usually what ends up happening, especially like if we use IBM as an example, IBM's obviously been around for a long time, they have a ton of systems. They're not just like saying, all right, we're shutting down IBM for the next 5 years while we adopt Skyflow. I mean, that would be great for us, but they're not doing that because it's just not reasonable to do. But they have essentially new initiatives. In this case, they have a new digital health initiative. So it's a new project, and it makes sense to essentially build that product from the ground up using sort of the best-in-class solution. So they're taking those new product lines and they're doing it, and then slowly over time you essentially adopt the pattern. Just like most people, even when they go from on-prem to cloud, they don't just shut down. Like Netflix didn't just shut down and move to AWS. They did it incrementally over time, starting with new projects and then eventually migrating products. So that's usually people have specific use cases they need to solve today that are like their biggest pain point. They start there and then they add over time. Yes? That's a great question. So when it comes to hacking, I think every system in the world is vulnerable. You have to assume that anybody can get into any system if they put enough effort into it. But there's still things that you can do from a best practices standpoint. So we are both, from a third-party auditing standpoint, like SOC 2 compliant, PCI level 1 compliant, HIPAA compliant, and have a number of different certifications. So we're following sort of industry best practices for essentially third-party services, saying, yes, you're following the best security processes. We also use external pen testers, bug bounties, and all that kind of stuff that you would normally use. And then the other thing is, if you're comparing this to taking on this challenge yourself, this is the only thing we do. So like everybody that we've hired in the company like 60 engineers, all they do is think about this problem, and they have expertise in this. We have an entire team of PhDs in encryption that are just constantly looking at different encryption models and how can we make that essentially enterprise-grade performant and do the types of things that we need to do. Outside of Apple, it's pretty hard to find more engineers dedicated to this problem than what we have right now. And then our head of security and compliance has over 50 patents in database security. He basically, 20 years, he worked at Oracle in the early days of Oracle, and he's invented most of the modern database security that we all take for granted. So that's essentially how we do it. Any other questions? You look like you might have a question. So we do have we don't have like yet anyway, like a fully self-serve, just sign up. But essentially, we do have a try environment that usually where people start with. And if you want to try that out, feel free to email me, and I can hook you up. Yeah. And I run a webinar every couple weeks too. Yeah, go ahead. Great question. It's a SaaS product. We do deploy. It's essentially your vault. We deploy via VPC, so it's like on-prem cloud. So essentially, you have a secure link in a production environment to the vault. So you're the only one with access, but it's not an on-prem solution. I think someone back here had a question as well. Yeah.
So my only concern would be, scale. Mm-hmm. So do you publish any benchmarks or anything, performance data?
We don't publish any performance data, but essentially, if you engage with us and you're at a point where we're having those kinds of conversations, we can certainly share performance metrics. But it hasn't been a problem so far, and as I mentioned, we work with some pretty large-scale players in the world. IBM. All right, I think we got to transition to the next person, so I'll give them a chance to stand up. But if you have more questions, feel free to track me down. Thank you.